will be down here, I believe. I think it might be a little harder for me to be up here. I'll try. Okay, but good morning. My name is Brian Butcher, and I'm here with BESS Technologies. It consists of Isaac Lund, Ben Bax, Fernando Baqueras, and Jeho Lee, and myself. And BESS Technology stands for Battery Energy Storage System Technologies. And this is our presentation that we gave at the Tech Valley Business Plan Competition. BESS Technologies. What is our mission? Our mission is to deliver high-efficiency lithium-ion batteries compared to current lithium-ion batteries out on the market. How do we plan to do this? Develop manufacturable silicon anode nanowire technology that is cost-effective and decreases. It's a cost-effective way to increase battery storage life and storage capacity. We do this also by decreasing the battery size, and I'll get into more details in a couple more slides. But our vision can be broken into short, mid, and long-term goals. Short-term, become a prominent battery supplier to the auto EV market. Mid-term, capture 10% of the auto EV market. Long-term, expand to other sectors of the total transportation EV market, and then potentially to other sectors, say portable electronics and other home and commercial applications. The total EV, or the total transportation market, has the same need for battery performance and efficiency. That can range all the way from locomotives to buses to the full-size battery electric and the hybrid vehicle. We chose to start our company based on the full-size battery electric and the hybrid vehicle. Why? Well, let the numbers do the talking a little bit. By 2015, the lithium-ion EV battery market is projected, this is a study done at MIT, to be $8 billion with a compound annual growth rate of 56%. I apologize, it seemed to be cut off a little bit. This graph, if you look on the left-hand side, this axis is the number of, corresponds to this bar per year, all the way down, and it corresponds to the number of vehicles that are being made every year. The other axis on this side corresponds to this bar, all the way. That's the number of vehicles in fleet are in the market as we speak. So if you look in 2010, the majority of the cars being made, the majority of cars being made and the number that are already out there on the road are mainly gas-guzzling cars. A couple of hybrids are being made, not that many being driven. But if you notice, by 2020, the hybrid vehicle market is supposed to really pick up, and that's followed by the the full-size electric battery vehicle by 2030 to take up most of the market. Oops. Sorry, I'm having a couple technical difficulties. So, by 2030, these are the number of full-size battery electric vehicles that will be being made. This is a number that should be driven on the road. BESS Tech is really trying to capture the market of the green and blue here. As you notice, the gas-guzzling cars should go down. So we're trying to position ourselves as a major supplier to the fast-growing EV market. Let's see. Okay, so how do we plan to do this, right? So this is our technology. Our technology is a high surface area silicon nanowire anode. That's what we're focusing right now. Silicon is theoretically optimal storage material for lithium ions. Right now, in the current market, graphite is mainly used for the anode. But the energy storage density for graphite doesn't even compare with silicon. If you look over here, the energy storage density is extremely high compared to the graphite. What does that mean? It means that potentially, in theory, silicon can store a lot more energy than graphite. There's a problem, though. Most anodes that use silicon technology are thin films. And the rigid silicon thin films expand when they absorb all of this lithium, right, resulting in a lot of stress and pulverization that happens here. The rigid silicon film can expand during charging by over 400%. Silicon films thus stress and detach, resulting in poor energy storage and battery performance. The BESS Tech solution is basically, why make them rigid? We can make them out of flexible silicon nanowires. On the nanoscale, silicon, or the different materials become flexible that were once rigid on the macro scale. We're taking advantage of this by making nanowires and using them to increase the surface area through our proprietary growth method. These are some of our results here that we have. Our anode will consist of an array of nanowires. And the whole point is have flexible silicon nanowires instead of silicon films to reduce the stress that is seen here so that we can maximize the energy density seen here. This nanowire array also stores lithium content, as I said here, but it also translates into a longer time that you have to travel, or you can travel before you need to recharge your battery, because it can store more density. So BESS is aiming to capture the full benefit of the silicon anode performance based on our growth methods here, as compared to what the competitors have. So what is our business model? Our business model can be described with an analogy. Intel is to computers as BESS is to smaller, efficient batteries. Our niche is to be able to create these smaller, more efficient batteries via proprietary manufacturing, manufactured SI nanowire anodes. This enables this enables our customer to do one of two things. They can create a battery of the same size that has a higher efficiency, or we can make a smaller battery that has the same capacity and energy storage that they already have. It gives them options. It gives them a better array of geometry and design that they can do with their battery. Our key strategies for doing this short term is to start with the high profit margin market, such as the EV market, like I explained before. We start with pilot programs, or we're trying to get into the pilot programs with some of these EV manufacturers. And long term, we seek other markets that are high performance demands and have higher growth rates. But right now, that's out of our scope because we're trying to build up our experience with the EV market. First thing we need to look at is our competition, because we do have a lot of competition. Some of these competitors, though, may end up becoming our customers because we're focusing right now on our anode technology, and we could actually sell to them our anode. You notice the lithium battery target markets of each one of these companies. These are the established companies, and these are the startups. If you notice this company right here, that's a pretty big target market. They didn't start that way, though. They started with supplying battery solutions to power tools. We're going to do the same thing. But we're going to supply the anode to the EV market. We're going to start there, and then we're going to expand later. We're going to do the same type of strategy. Start small, and then expand to the big market. Let's see. So we're currently working on a prototype for our anode, and it is being tested against a cathode for the lithium-ion phosphate, which is one of the main cathodes that's being used out in the industry today. And let's see what we have. So to look at our potential customers, this being most of our competition, our potential customers would see this on a chart. So if you notice the battery weight, this kind of brings it home. So the battery weight here normally for the batteries now out on the market, this is our battery weight, right? This is the range, and you can see our range is similar, but we also give like 100% reduction in weight to our batteries. This really shows that our battery can give a lot of different options, or our anode can give a lot of different options for our battery. And let's see, we can give the same range with less space, and the manufacturing design freedom is given to our customers because of our anode solutions. So we know that we have a lot to do. The first thing, or milestones, is to get us out of the lab and into the market. Technical milestones, we expand our IP portfolio. We're currently working on protecting our IP and further develop our prototype. Next would be packaging and safety, circuit design, and optimizing our manufacturing process would be next. Scaling up our manufacturing. Our financial milestones obtain a small SBIR and a federal grant, which will further develop our prototype. We're applying for the CNSC iClean incubator program, and I've actually talked to a couple of you guys as well. Before this started, there's a couple of different incubators that we can look at as well. This is our main option because we are CNSC students. Next, we can hire executives with experience in commercialization to help us get forward after we get our feet off the ground, initial stages. We establish our manufacturing facilities, and our intentions are to go public. However, if we have to have an exit plan, it'll be to be acquired after we go public, if and only if, right? So, our financial estimates are based on a 500 battery pilot program that doubles annually. If I can draw your attention here to our seed money, this may seem a little high, but in 2009, the U.S. government made $2.3 billion into the economy based off of the electric vehicle and battery manufacturing initiative. There's going to be a lot more money that's given out because of this. Maybe a little bit less money because of the stimulus, but there will be some. And we figure that this is a conservatively feasible estimate for seed money once we apply our grants. Notice our depth of hole is 3 years, and then we expect to go positive after round 6. This can be explained graphically. If you look, our time to positive cash flow, if you convert this into 2010 dollars, so we know we're not going to start in 2010 because we're actually there in we're actually here in 2010 now, but by 2011 is when this is actually going to start. But if you take it into 2010 dollars now, in 6 years, we expect to approach somewhere around $6 million. The graph on the right shows that we know that you potential investors are looking for their rate of return, and we expect like a minimum of 15% annual rate of return after we get our initial out of the hole phase. And we really believe that we have an intelligent team, and I apologize for my little bit of stuttering because it's kind of early in the morning, but we have the people is really what matters and what we have in our technology. And those people can be here, written here, starting with myself, and then lead engineers, Isaac Lund and Jeho Lee, who has more degrees than all of us here put together. Our CFO, Robert Himes, and Fernando Gomez Baquero, and Ben Bax, our advisors. And we have a lot of engineering support and scientific support from the College of Nanoscale Science and Engineering. And thank you for your attention. That's all I have. Anyway, we'll entertain any questions now. You guys want to join me?
Not really.
Question? I think I'm going to turn it off. Sorry.
From a strictly engineering standpoint, what do you think your biggest technical challenge is, and how you going to address it? Real-time testing and testing in general. You're talking about real power.
All right.
Safety.
Okay. Well, our biggest challenge is to, first off, right now is to build a successful prototype. Is our first challenge. After that will be harnessing all of the main amount of energy that we can, the most amount of energy we can from the SI anode. The biggest challenge will basically be to manufacture this, right? To get it out into the market, you know.
Well, and to address your concern about the testing and like that, we have basically a full complement of equipment at CNSC where we're, in the iClean facility, we'll have access to all of this equipment. So we will, to put it simply, test the hell out of it
Right.
before we even, present this to anybody like that. So we know it's going to work.
I noticed the Prius battery is 50 kilos and yours is 82 kilos and everybody else is like 200 kilos. What's going on with the Prius battery?
Well, the Prius battery is more of a hybrid, too. So it's not a full EV battery, but he knows a little bit more about it. Usually.
Yeah, whoa.
It's kind of. Throws you off a little bit.
The Prius is a smaller battery because it recharges using a gas engine. It is a hybrid battery, and so it only goes, I think, 30 miles on the actual battery power, and then the rest of the time it uses the engine to either charge it or to run the car. So
it doesn't need to be as big. That's
Yeah.
basically what the answer is. But that we're still going in that market too. We're doing the hybrid and the EV too. So.
You talked about the manufacturing. You mentioned the scalability of the manufacturing from a technical point of view. Have you thought about that? I mean, is taking it from the lab bench
Yes.
to a factory line, is that something that you thought about?
Yes, we have thought about it. I assume. Yeah. We have thought about it, and we expect to hit that phase in maybe half a year from now when we actually get our IP off the ground and we get established in the iClean, which is at CNSC. Because right now our main issue is that we don't want to give any more patents to CNSC than we have to, because we have a lot more ideas. So we're trying to make sure that they just have this one, right? And then we have the ability to stay under the iClean window and develop more of our manufacturing patents that way. And that will be done here in upstate New York. So.
Also to your concern about scalability, this technology is it's just based out of semiconductor processing technology, right? And that's one thing that we really know of. And definitely we have a lot of knowledge about that right now at the CNSC, and we've been working with that for almost, it's going to be, CNSC is going to have like 6 years now working on that technology. So it really uses that base technology. We know how to use it, and we know that we can scale it up, and not only scale it up successfully, but quickly, because there's always a knowledge curve that you have to take. But if there's one thing that we're very good at the semiconductor industry, is actually learning pretty fast. So that's going to come to our advantage when we scale up this technology. No, it's actually just very ingenious and very cool semiconductor technology. Yeah.
It's at the end of the day, it's silicon, and we actually CNSC.
Yeah.
Once we get the rental rate of their tools settled, we'll be able to use all of their facilities that are very used to silicon, because it's a manufacturing place for the semiconductor industry. So, yes, sir.
Israel has a huge initiative to move to EV, get off of oil. Have you looked at any of the opportunities that might exist with partnering with them? They have a huge budget for development, and their technology is basically use a battery that you use gas and you pull into a station to replace the battery, rather than
Like replacement batteries at the charging stations, as opposed to, yeah, the swap. Can you repeat? Like, we've thought about it.
the question is, have you looked at any of the initiatives there? Is there an opportunity for you to do some teaming in terms of R&D?
Yes.
You're already pouring money into that market.
Yes, there is. We have looked at it a little bit, but you want to try? But
There's
it's
also, yeah, I mean, as you say, it's not only Israel. I mean, a lot of different countries are actually investing, a lot of money on battery technologies, and even the U.S. has now a big battery consortium, also made out of big automotive companies, Ford, GM. So the opportunities out there, we're open to any opportunities. Of course, emerging markets are huge, a huge opportunity. I think that at the stage that we're at right now is we really want to understand the technology and make it better, and and develop this prototype, and it's going to come organically out of that, right? Once you have the great technology, then definitely we're open to working with everybody in the world that actually wants to apply this technology.
I'll ask them a question to inspire some conversation. I realize that this presentation is part of a business plan competition. How real do you think your business is?
we wouldn't be standing up here if we didn't.
right, exactly.
Yes.
We feel that this is a solid business idea because it gives us the ability to supply a certain key component to battery manufacturers on a fundamental level, the anode, the battery doesn't work without it. So as far as building a business plan around that, we feel that it's a really good, solid idea. Is that we're in it for the long haul, actually. So good presentation or bad presentation.
I'm wondering how this technology, if you've begun to explore relationships with alternative energy, because the solar business has this natural challenge and hurdle every time the sun goes down. And same thing with wind when the wind doesn't blow. These are huge sectors that are evolving, but they really need battery capacity to get over the hump.
Right, and one of those, with the wind power that you just mentioned, one of the key areas that our technology could come in handy is the ability to store that wind energy when the infrastructure is actually there, hooked up to your house, when everybody has these EV cars, to store this wind energy in a more efficient battery inside the cars. Because the main problem with wind storage is that where do you store, or you can't store it, right? You can generate it. So if we can store it in our cars, not our, but our batteries, it would be better. So.
Well, yeah, and to that point as well, we're focusing on EV, electric vehicle market because of the information that's there. But yeah, definitely one of the longer term solutions that we're looking for will be larger kind of what do you call it, power grade, battery solutions for that.
And also,
those folks.
we could move. Our initial plan was to move into the home battery storage for homes, but it's not, the infrastructure is not there yet. But we expect different other solutions for alternative energy to come up for our batteries later on. So, yes, sir.
What is the range limitation? Is it the size or weight of the battery? And if so, if you double the size of the battery, do you double how does it scale with the range? Because I would think.
You can get the numbers.
If you talk about 6,000 pound vehicle, I don't really care if you reduce it by 10%, 50%.
Well, it's one of your options. You can either reduce it, or you can keep the same energy, or you can keep the same size. And because our key technology is a high energy, a high surface density, which allows you to store more lithium in the anode. So if you have the same battery with the same size, you can increase the capacity. That's one option. But you're talking about focus on the one where you have the other option to reduce the battery size. Our whole thing is to give our customer options.
What is the priority from the vehicle industry? Are they really concerned about range?
No, it's about capacity.
It's capacity. Capacity dictates, the size that you have, and then also the range that you have. So having a higher capacity material like silicon, it allows you to shrink the size but maintain the same range, or keep the same size and increase the range. So.